This video will cover the second part of Pre-Calc Notes 2.2. Remember in the first video we were talking about graphing degree 3, 4, or 5 polynomials. We're going to continue that. This next example, you notice that I didn't turn the graphing calculator on. I'd like for us to try to graph this without using the graphing calculator at all, just by talking about all of the characteristics of this type of graph that we have talked about in the previous video. So here's my thought process. First thing I notice, it's degree 4, so it's either going to be a W or it's going to be an M. If my leading coefficient is negative, it's going to be an M-shaped graph. With that being said, if my graph is an M-shaped graph and it's degree 4, there should be 3 turning points, and I should also have 4 zeros, or at most 4 zeros. I may not get exactly 4 zeros. I may get less than that if one of them is a double 0. So what I'm going to do first is I'm going to actually find the x-intercepts, plot those, and then pick numbers that are in between that to get the rest of my graph. Again, I know my graph should look something like this. So to find the x-intercepts, I'm going to factor this by pulling out the greatest common factor, 2x squared. And this is going to give me x. Actually, it's going to give me negative x squared plus 4. Setting these equal to 0 then, 2x squared equals 0, negative x squared plus 4 equals 0. I'll divide by 2, take the square root, and I'm really going to get 2 values of 0 here. So this is actually going to give me 2 of my zeros. So I'm just going to make a little note underneath that this is 2 zeros. Because of the fact that this was x squared. If you want to think about it as plus or minus 0, although 0 cannot, have 2, or it doesn't have a assigned value as positive or negative, but I'm going to get 2 zeros out of here. I should get other 2 zeros out of this. I'm actually going to add the x squared to the other side just to keep that positive. So now 4 is equal to x squared. Get rid of the squared by taking the square root, and again, this is going to give me 2 zeros. Plus or minus 2. So I'm saying that the zeros for this problem are going to occur at 0, 2, and negative 2. So another way of saying that is the x-intercepts are 0, 2, and negative 2. So let's plot those. 0, 2, and negative 2. So my graph is going to, have to come through these points. Something like this is what I'm thinking. And again, that's just a rough idea. Again, don't plot that because that's not exact. The only things that we want to plot for sure are the x and y intercepts. But I just wanted to give you an idea of what it will look like. So the next thing that I want to do is I know that a turning point has to be between my 2 zeros. So a good point between here would be negative 1. So let's try to use negative 1 in our table and see what we get. Well, if I plug negative 1 into this equation, I end up getting a 6. So at negative 1, I get 1, 2, 3, 4, 5, 6. Okay. Another another turning point has to be between my other 2 x-intercepts. So that would be at positive 1. So at positive 1, I end up getting a positive 6 also if I plug 1 into here. So now what I'm noticing is my graph is going to look something like this. If my shape has to be like that, it's going to start way down here, come up, it's going to turn, and when I get to 0 here, because I'm getting 2 zeros there, it means it's going to turn right again at that point. It's not going to go down further and turn. It's going to turn right there, come up to the top, turn again, and go down. And that's what my graph should look like. So I was able to graph this without looking at the graphing calculator, just by talking about the number of turning points, which is 3, and I've got those 3, so it starts here, turns once, turns twice, turns the third time there, so those are my 3 turning points, and my 4 zeros are really 1, 2, and then this one counts as 2. So I was able to, and then just know the basic shape of it being an M-shaped graph because of the fact that it's negative. I can get my graph. Let's turn on the graphing calculator and check to see if I get the same shape. So we can see by looking at the graphing calculator that we are getting that M-like shape. And we're getting our intercepts here at 2, -2, 0, and 2. And we got our turning points up here. There was one turning point, and a turning point. So again, my graph does look like what it should. And again, I encourage you to try to do this without the graphing calculator at first, so you can get an idea of these basic characteristics. You're going to be much more successful at graphing if you don't rely heavily on the technology. The technology is great, but don't let that limit you in terms of not knowing these characteristics. Use it to kind of check to make sure that your characteristics about what you think the graph should look like is correct. So use it as an aid to check, not as the only resource that you'll use to graph them. For this next example, I want to talk about the intermediate value theory, and this is going to be helpful when we are noticing that a graph is not factorable, so I don't know what the x-intercept is by factoring it. I can't use the quadratic formula, so what are my resources, or what are the ways that I can figure out what this x-intercept is? Well, a good thing that you have is the graphing calculator. So if I take a look at this graph, you'll notice that it appears that the intercept looks like it's somewhere between 1 and 1 and 2. And what I want you to pay attention to is if I show you the table, if I'm looking at values, if we start off at, let's say, -3, notice that my graph is negative, it's negative, it's negative, it's negative, it's negative, and then all of a sudden the y value is changing from negative to positive. That means where the y value changes from negative, so down here, to positive up here, that the graph has to cross the x-axis. So I know that my graph has to have a 0 somewhere between 1 and 2. And if I want to think specifically about what my what my value is with the x-intercept here, I've got a great feature on this graphing calculator, which is trace, where I can kind of just trace it along the graph, and I can try to get as close as possible to figuring out what this is. So notice that when x value is about 1.6, I'm at -0.28, so I'm not quite at 0. And when I go to the next one over, I'm at 1.78, which goes up to +0.5. So I know that my intercept is occurring somewhere between 1.6 and 1.7. So I can get a good idea, not an exact idea, but a very, very close idea based upon the graphing calculator here that my x-intercept has to be, maybe 1.65. We could actually calculate and see the value at 1.65. It looks like it's -0.23. Let's maybe make it a little bit bigger. If I hit calculate again, -1, +1 point, let's say 7. Now I'm at 0.02, so that's a lot closer. Let's see what happens if I go to 1.6999. I get a little bit closer to 0. So I know it's not quite 1.7. And I could keep playing with this, for a while. 1.689. Let's try that. That's 0.03. That's -0.03. So that's even, a little bit down in the negatives now. So I'm pretty comfortable by saying that the value of this would be 1.6999. That's about as close as I'm able to get it to 0. So again, the graphing calculator, just by using the trace function or the calculate function, once you've kind of narrowed it down, you can get a pretty good idea of what your x-intercept is in this problem. So we should add some notes to our sheet so we can use our notes later on when we talk about the intermediate value theory. So let's add some notes here. So we talked about checking to see, looking for the points where we have changes in sign in the y coordinates. So here at -1, we're at -4, then we're at negative 2, then we're at negative 2 again, and then we're at positive 2. So right here we said that there should be a 0. So our x-intercept is between 1 and 2. And we used our trace function to get even closer. And we said that it was between 1.6 and 1.7. And then just by using the calculate function on our graphing calculator, we were able to say that's probably about 1.699 was as close as we can get. So on a test, I probably won't ask you to come up with this number. What I'm going to ask you to come up with is the interval that it's between. So we can say that it is a number between 1 and 2. Again, we got very specific in coming up with the exact value, but on a test I'm just going to ask you to come up with the x values that it would be between. I know it's a number between 1 and 2.